Hello, so today we're going to be talking about similar polygons. So previously we've talked about congruent, so the symbol we use for congruent is the equal sign with the squiggly little mark there. But when we say similar, we just use the squiggly part. So that, if you ever see just that, that means similar. And we're going to talk about what that means right now. So again, when they were congruent, two shapes had exactly the same size, lengths, and they had exactly the same angles. When two shapes are similar, they still have the same angle measures, but they are different sizes usually. So corresponding angles are still congruent, but corresponding sides are proportional. So they're not going to be the same length, they're going to be proportional. So they're going to have a scale factor. So in example one, and then this is the symbol we use, just like I mentioned before. In example one, we have to list all the congruent angles. So the corresponding angle to R. So angle R is corresponding to angle X. So angle R is congruent to angle X. Angle T is corresponding to angle Z. So those two are congruent. So angle T is congruent to angle Z. And then the last one, S and Y are corresponding. So those two are congruent. So angle S is congruent to angle Y. So part B, check that the ratios of the corresponding side lengths are equal. So ZY is corresponding to TS. So those two should form some type of proportion. So ZY is 18 in length, TS is 30. So if I reduce the fraction, I know that 6 goes into 18 and 30. So 6 goes into 18 3 times. 6 goes into 30 5 times. So 3/5 would be that as a reduced fraction. Now I'm going to look at another side. So let's take a look at ZX right here. So ZX is corresponding to TR. So ZX and TR are going to be proportional. So ZX is 15, TR is 25. So if I reduce this fraction, 15 over 25, I know that 5 goes into both of these numbers. So 5 goes into 15 3 times, 5 goes into 25 5 times. So again, my reduced fraction is 3/5. So far, the two sides that I've checked both have a scale factor of 3/5. That last side, so XY and RS, those are proportional to each other, or corresponding, so they should be proportional. So XY over RS. XY was 12, RS is 20. So if I reduce that fraction, I know that 4 goes into 12 3 times and 4 goes into 20 5 times. So notice that we get 3/5 as the scale factor for each side. So these triangles are similar because they all have the same proportion on their side lengths and all the corresponding angles are congruent. So moving on to example 2. So the polygons are similar. What is the scale factor? So it tells us they're similar. So we know the sides are proportional and we know all the corresponding angles are congruent, which they list here for us. So if I want to find the scale factor, I can take one of the sides. I'll start with, on the top, I'm going to put one on the right. So it doesn't really matter what side you choose. I'll choose ZW. So which side is ZW corresponding to? Well, notice that W is a 90-degree angle and Z has that one arc on it. So over here on this shape on the left, I want to look at the 90-degree angle and the angle with one arc, because that will be the side that is corresponding with ZW, and that happens to be FJ. So ZW is 20, FJ is 16, so reduce, 4 goes into each number, so 4 goes into 25 times, and 4 goes into 16 4 times, so 5/4 is our scale factor. If I wanted to verify that this is correct, I could choose another side to find the proportion of. So let's say we wanted to look at YX. So YX is 30, so that comes in between the angle with 3 arcs, the angle with 2 arcs. So 3 arcs, 2 arcs, so that'd be this side. So YX and GH should be proportional. So we should get 5/4 again. So yx was 30, gh was 24. So I know that 6 goes into both of these numbers. 6 goes into 30 5 times. 6 goes into 24 4 times. So again, our proportion is 5/4. So if I did that for each side, I would get 5/4. So the scale factor is 5/4. So this is our answer. You can also use proportions to find the unknown lengths. So if I know that these two shapes are similar, and that's what this says right here. So ABCD is similar to QRST. So again, that means they have all corresponding angles are congruent. So make our little marks here. What is the scale factor of the two polygons? And then find the value for x. So first thing we got to do is find the scale factor. So I'm going to choose two sides that are corresponding. It doesn't matter which one I want to start with. I'll start with QT. So which side is QT corresponding to in the bigger one? So Q is the angle with one arc. T is the angle with 4 arcs. So the angle with one arc is A and then 4 arcs is D. So this side would be corresponding to QT. So that's 80. So QT is 5, 80 is 10. If I reduce that, 5 over 10 reduces to 1/2. So scale factor is 1/2, or should be 1/2. So if I wanted to find the value of x, I could set up a little proportion here. So I know that this side, BC, is between 2 arcs and 3 arcs. So 2 arcs and 3 arcs, RS. So I know that RS is corresponding to BC. So RS is 4, BC is x. And then I can choose two other sides that are corresponding. So let's go with, we could use our two green ones. So QT was 5 and AD was 10. But instead of writing 5 over 10, we could write 4 over x equals 1 over 2 because 5 over 10 reduces to 1 over 2. You don't have to do that, but it'll just make the numbers more simple when you're multiplying. So now, whenever you have two fractions equal to each other, so they're separated by equal sign, we can cross multiply. So I'm going to multiply across. So 4 times 2 is 8. I keep the equal sign right in the middle. 1 times x is just x. So x equals 8. Now moving on to the next page. Example 4, we got somebody with a picture that is 8 by 10 inches. He wants to print in a reduced size. So he wants the height of the new picture to be 6. And he wants the length to be something that we need to figure out. So again, I can use a proportion. So the side that matches up with x would be 10. So 10 over x is equal to, so I use the big picture first. So I have to use the big picture first on the second fraction. So which side is corresponding to 10? That would be x. Oops, I did this incorrectly. Hold on one second. Start this over. So 10 and x are corresponding, and then 8 and 6 are corresponding. Oops, my bad. So cross multiply. 10 times 6 is 60. Keep the equal sign in the middle. 8 times x is 8x. Let's use a color you can actually see. So divide both sides by 8. So x is equal to 60 over 8. So if I reduce this, that would be 7.5. So that means x would be 7.5 inches. So there's other ways you could set up the proportion too. So we could have also done 10 over 8. And then what side's corresponding to 10? So I kind of mixed these up when I was doing it first. Equals x over 6. And notice we'll still get the same thing. So when we cross multiply, you get 60 equals 8x. So there's a couple different ways you could set up those proportions. So example 5, what are the pairs of congruent angles? So for part A, H is going to be congruent. So H is first, C is first. So that means H and C are congruent. J is second, so angle J is going to be congruent with the second one on this one, so end. And then angle K and angle C, or excuse me, angle K and angle D are congruent. So for part B, what is the proportion for the ratios of the corresponding sides? So let's look at the first side. So the first two letters are HJ. Those have to be corresponding with the first two letters of the second one, so CN. If I choose the second two letters, JK, so JK has to be corresponding with the second two letters over here, so ND. And if I look at the first and third, so HK, that has to be corresponding with the first and third over here, which would be CD. So if they don't have a picture drawn and they just give you this, you could still find the proportion that way. So in our last example here, you want to make a scale drawing of New York City's Empire State Building using the scale of 1 inch equals 250 feet. The building is 250 feet tall, so how tall should you make it in your drawing if you want to make it perfectly scaled to fit the actual height of the New York City's Empire State Building? So first thing I know that for every 250 feet in my drawing, I'm going to make it 1 inch. So the top of my fraction is the actual height. The bottom of my fraction is the drawing height. So on the other side, the actual height of the building is 1250. So I'm going to put that on top because I have the actual height on top over here. The drawing height is what I'm trying to figure out. So I don't know what that is, so it's going to be X. So now I have a proportion, so I can cross multiply because two fractions are on the opposite sides of an equal sign. So equal sign is going to stay in the middle. So 1 times 1250 is 1250. 250 times X is 250X. So divide both sides by 250, and we get X equals 5. Oops, that's not a 5. So it should be 5 inches tall in our drawing.